Today I'm going to open up and just report back on the Harmony project. Last year, we were fortunate enough to be here at this conference when the Harmony project was announced. That one is now in implementation. Show you some pictures from that, and then I'm going to talk about the economics of bioenergy for mines. So the Harmony project, the project owner is Harmony Gold Mining Company. They're the developer as well, Harmony Central Projects. Our company, Selectra, is the consultant on the project. We designed the architecture, they're implementing it, they own it. We're busy with the agricultural work package. I'll take you through some pictures. The order was placed in August 2014, and then there was a mad rush. The contractors' orders were placed in October, mobilization in November, we broke ground in December, we planted our first crop in January, and the first harvest was in May. So here's some pictures of the first harvest, the first crop. The decision was made to go with sorghum, which is a late flowering sorghum. 15th of March over there. 5th and 6th of May the harvesting took place. And the crop is being ensiled, and we're storing it as a bank because the project calls for keeping a year's supply of raw material in case we have a crop failure down the line. The engineering work package is now started. For those of you, I don't know if we announced it last time, but those Pachuca tanks, those old Pachuca tanks on site over there, we're refurbishing them to become the fermentation tanks, and we're using the infrastructure that's already there. Right, the role of bioenergy in solving a mine's energy crisis. We're talking about the economics of bioenergy for mines. Just to get the definition right of bioenergy, bioenergy is energy from the sun stored in chemical form and derived from the conversion of biomass. So in plants, they get the bioenergy through photosynthesis. Animals, they get it through eating the plants. Bioenergy is a form of renewable energy. Yesterday there was quite a discussion, and Egmont came out and he said, you know, what do mines want? Nobody is listening to them, nobody is looking at the real issues, nobody is giving them what they want. So the question we have to come back to is, what do mines want? And it was striking to think at the panel that everybody had a story that actually gave a different insight into what we're talking about. Gerard van der Berg, he mentioned that their energy cost or the electricity cost had doubled from 6 to 12% of utility costs in a short period of time. Krista Oliver of Comba, 70% of the energy costs are diesel. Very interesting. The next Kubat from Acacia, they're paying 25 US cents a kilowatt hour. So it makes us rethink this a little bit. If we're looking at the energy drivers are the things that make it happen, but it's the real life examples that actually cause it to happen from a developer's point of view. Ernst & Young, or EY, did a lot of work and study and looking at the drivers, and top of their list is cost and energy security. But they also list other things as energy supply for remote areas, social license to operate, greenhouse gas mitigation, expectations from investors, and corporate leadership and innovation. I think we can answer Egmont quite easy. It's very, very simple. Mines are looking for cost-effective, reliable solutions. That's the bottom line. Cost-effective, reliable solution. I think if we take that a step further, Harmony were quite visionary because their project charter called for 5 megawatts of bioenergy, growing crops on impacted land, non-food crops on impacted land, mine impacted land, supporting community programs. So their definition worked for them. Somebody who's off the grid in the middle of Africa has got a different definition which works for them. There are kind of 3 different bioenergy opportunities that I'm going to look at. Baseload or prime power, critical power, and what I call SI in energy. Baseload and prime power, it's really to power off-grid mines, normally to replace diesel in remote places. Critical power, that came to us from one of our customers who said, you know what, I need this 2 megawatt because when Eskom goes, then what do we do? And they've got furnaces and there's a problem. So they need that 2 megawatt. And diesel, you know, wasn't, what can we do in place of diesel? We'll get to that. SI energy is social investment energy. It's energy produced on impacted land in support of social and rehabilitation programs. So baseload prime power, there the sweet spot I think for mines is about 10 to 35 megawatts. What you're doing there is you're growing an energy crop, taking that energy, combusting it, steam, high pressure steam boilers producing the energy. The number of challenges, other than growing the crop, the fuel is wet, corrosive, lots of ash. Got to be able to deal with it. Increasingly, the emission standards have to be met, which is good. And also the ability to supply, to operate on multiple fuel types. Just in case this product is no longer available, we can operate on that product, on that feedstock. So if we look at a typical footprint for this, it's about 100 hectare per megawatt of electricity. And as I said earlier, sweet spot for mines, probably the 10 to 50 megawatt range. Above 50 megawatts, I think the ground requirement gets a bit big. If you look there, the 30 megawatt installation in a tropical type climate needs a crop with about an 8-kilometer radius. The capex, 30 to 40 million rand a megawatt. These are very generalized figures. And when I talk about OPEX, I talk about there is a certain amount of redemption of capex in that is associated with this type of technology. So in terms of, if we were going to sell the power, or anybody similar to us, we're going to sell the power, probably at about 1 Rand 30 to 1 Rand 75 a kilowatt hour. In critical power, as I said, electricity to supply critical process at times of power outages or rationing. And here we're looking at a smaller range, 1 to 10 megawatt. But this is the most challenging area for bioenergy to be. Eskom doesn't give you much notice. We heard about the call a number of times during the conference here. We're switching off. And then one needs to react. So typically this has been a diesel type operation. Our approach has been slightly differently. We said, okay, why don't we look at a base load, let's say a 2 megawatt if that's your critical power. Why don't we develop a base load 2 megawatt that you're going to run all the time and it's going to be cost effective? The answer that we found for that is a solar Stirling CSP biogas hybrid solution. The advantage is you're working off one engine, 2 different heat sources. So by combining the two, you get tremendous synergy in your capital spend. And this, I believe, can give you a very nice base rate power. If we look in small size, if you look, the footprint is about 50 hectares per megawatt. Operating range about 1 to 10 megawatt. And your capex, in line with most, 40 to 50 million per megawatt. An OPEX range of 90 to 1 rand 30. So now you say 90 to 1 rand 30 compared to what I'm paying Eskom today really doesn't work for me. It also doesn't work when you're looking at diesel power that you're only using 10%, 20% of the month. Because the diesel is more expensive per kilowatt hour, but you're not using it full time. What we're able to do though with this type of technology is to oversize the biogas side and use that power replacing other liquid fuels, and an average average cost across maybe 1 or 2 applications then is something that can work very well. Social investment energy, again, energy produced on impacted land in support of social and rehabilitation programs. Very importantly, must abide by the rules, must be cost effective, must be reliable. The social side of it comes afterwards. We talk about environmental return on investment. You know, up to now, remediation is a grudge purchase. It's something that mines have to do, but they get nothing back from it. The solution up to now is to return it to grassland, and there's legacy costs, there's ongoing maintenance costs. It doesn't bring anything. If we change the parameters a little bit and we look and we say, okay, let's produce, as in the case of Hartley, let's produce an energy crop on this ground. We take it, what is a liability, and we turn it into an asset within a year. And that's the bottom line and solution, is must be cost reliable and effective energy again. The footprint is 100 hectares per megawatt energy. The operating range is probably 1 to 3 megawatts. The capex 30 to 40 million rand per megawatt, and the OPEX is 1 rand 40 to 1 rand 75 a kilowatt hour. Now again, in this solution, very seldom would we suggest to actually produce electricity. If you think about it, the competition is Eskom. Eskom sits on top of the mine dump, cheapest coal in the world, government funding, and you know, coal, if we went and bought it at the wholesale level, probably cost us about 900 rand a ton, 30 rand a gigajoule. Now we've got to produce a crop, take it through, produce electricity. It doesn't work. But the fantastic thing about what we're doing here is the biogas can be used in other applications. And those applications have a much better turnaround, have a much better profitability. One such application is green gas, what we call green gas. This is bio-CNG. It's the biogas taken, cleaned up, compressed, and presented as a transport fuel. So now competition, instead of coal at 30 rand a gigajoule, we're competing against diesel at 329 rand a gigajoule. And this is with something that cost us 100 to 150 rand a gigajoule to produce. So this enables us to get the turnaround in terms of the profitability, but importantly it allows us to take land that is not suitable to grow energy crops on it, to produce that energy crop and to be profitable at the end of the day. If we look at green gas in a vehicle, this is an example of a kind of truck. The cost to upgrade the truck to run on dual fuel, which is a combination of diesel and bio-CNG, is around about 100,000 rand. We've seen that truck does in this example 100,000 kilometers a year, 250 days at 400 kilometers a day. It's not working too hard. Diesel consumption is 48 rand a liter, 48 liters per 100 kilometers, sorry, and we use 12 rand a liter. That truck can save us 107,000 rand by converting to the dual fuel. The reason is that our fuel spread, diesel fuel cost goes down from 576,000 rand to 374,000 rand. There are other advantages like bigger, longer ranges and things like that. But this is an example of saying, pick your fight, pick your competition, pick where you want to operate. Everybody says, let us make electricity. There are times to make electricity. There are places, there are technology. But really, there's sometimes one needs to look past electricity and say, look at the total energy. How can we operate within the total energy field? Is it feasible? Well, I know the Caterpillar guys are here. They, like every other truck producer, major truck producer, all changing over to natural gas. The comment I like, they're all in on natural gas. Cummins, MAN, everybody has got these in the range. So you can operate on a 100% CNG vehicle bought off the shelf, or you can operate with converting your existing fleet to run diesel and biogas together via CNG. So we get to the stage where we made the announcement last year about the Harmony Bioenergy project. For us, it's been a challenging and fruitful year. We've been kept rather busy. And we're happy to announce that we've set up a new division or new company called the Greenco Bioenergy, specifically targeting mines. The company's got two major shareholders, ourselves, Selectra, and the Greenco, who are the leading remediation and I'm getting mad here, closure specialists. So it's really a very, very solid and good mix. We understand the technology. We're able to put it together. The Greenco have been working on these impacted lands. They understand farming. They understand mining impacts. And once you understand the technology, always the risk will be in the ground, because that's the hidden part. That's the part that it becomes the guesswork. And through that, them bringing this technology, this understanding to the team, I think that it's going to be a very good year again. So, once again, I thank you, and maybe I must just take Selectra off. We're not throwing it away. Selectra carries on in the normal industrial field, but I'll put on Greenco Bioenergy now. Thank you very much.